So, in today's lesson, we're going to be looking at what calculus means and what calculus really is. So, this video is intended for anyone who's interested in finding out what calculus is or is going to take part in a course in the future to do with mathematics, which involves calculus, and maybe they want to get a bit of a head start or just want to understand some concepts without the use of too many technical terms. So, to put it simply, calculus is the study of variable rate of change, or rather, variable rates of change. Sorry. And I will explain what I mean by that, but maybe you can take a hint from the word variable here. Variable means something that is changing, really. And it sounds a bit strange, study of changing rates of change, but we'll get to that a bit later. So, let's just jump right in. Let's say we have a function defined as f of x equals x plus 4. We say this function is linear and not variable, and well, the reason for that is quite simple, really. If we take the graph of this function, just drawing a regular coordinate axis, we take some arbitrary points just to help us graph it. It would look something like this. So we can say this is f of x. And what you notice is, let's say at point x equals 0, y equals 4, and then at point x equals 1, well, 1 plus 4 is 5, so y is 5, and then at x equals 2, 2 plus 4 is 6, and y is 6. You'll notice that y is increasing at the same rate each time x increases by 1 unit. And that's why we get this straight line when we try to graph this function. Now, how about I take a function defined by f of x is equal to, I don't know, x squared. What if I graph this? How will it look like? Well, it turns out that this function will look like this, something like this. And it's pretty badly drawn. I apologize for that, but this is the general form of what f of x would look like in this case. So, how about we see how y changes with respect to x with this function? Well, when x is 0, y is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. Hold on a minute. So we've gone from 0 to 1 to 4. Y seems to be jumping ahead of itself here. It's not increasing at the same rate because, well, y was 0 when x was 0. Then y was 1 when x was 1. And suddenly y became 4 when x was 2. Now, most of you have probably come to the conclusion now that in this case, y is increasing at a variable rate with respect to a unit increase in x, or an increase of x by 1 step. And you would be right. So this is the classic case of a function where y increases at a different rate each time x increases, really. Now, if we wanted to find the rate of change of y with respect to x, with this function, well, you may have learned in class that we can use something called the gradient, or rise over run, at any given point. So let's say this is 3. At 3, y is 7. And at 0, y is 4. So the rise would be 3. The run would be 3 as well. And as gradient is rise over run, so the gradient of this line would be 1. And that would give you the rate of change. Now, we can't do that with a curve like this, because the gradient of this curve is constantly changing, or the rate of change with y with respect to x is never the same. It's always changing. It's either getting steeper here or less steep here. So how, if we wanted to, how would we find the gradient of this curve at some random point, let's say at x equals 2? Well, that's where calculus comes into play. And calculus basically allows you to calculate the gradient of this curve at any point in the function's domain. So that's one of the things calculus allows you to do. And it's part of something called differential calculus, which we'll get into later. But how about we try this, and we try calculating the gradient of this curve at different points. Well, gradient is rise over run, right? So if I wanted to calculate the gradient at this point, how would I do it? If I took another point and used the rise over run formula, I wouldn't be calculating the gradient of the curve at this point. I would really just be calculating the gradient of the secant line, or the line produced from these 2 points, not the gradient of the curve at this very point. So what would I do? Well, this guy Newton, he thought of a very clever way of working out the gradient of this point, and the way he worked it out was he said, what if we calculate the gradient of the tangent to that point? Because the tangent, as you probably know, is a line that only touches a curve at one point. So what if we calculate the gradient of the tangent to the point we want to know the gradient of? And that's how we do it nowadays. We use the gradient of the tangent to calculate the gradient of the curve at that point. So this is just a really simple introduction to what calculus really is, what's its basic application, and really from here there are many different things you can do. There are many methods of working out the equation of the tangent to any point on a curve. Calculus has, or Newton, he thought of a very, very clever way of doing just that, which I will be explaining in my next video. So thank you very much for watching.